Hello all, welcome to this tutorial in the course of Mathematical Foundations of Machine Learning. In this tutorial, we will be going ahead and understanding some of the basic constructs of Python programming language. So during this course, we will be having a lot of exercises in which we will be hand coding most of the ideas that we'll be learning throughout the course to understand how they work. Now, to do so, we want to do it on a system. For that, we will be using Google Colab. Okay, so if you prefer, you can install Anaconda kind of distributions on your systems, and then you can run locally. At the fag end of our course, we might be needing GPUs, because of which we will be using Colab, now wherein which for certain amount of duration, Google will be giving us GPUs for free. So apart from that, we don't expect that you should have any compute. So coming to the prerequisites, so we understand that we assume that uh, you are comfortable with programming constructs. So we are assuming that at least you know some programming language, may not be Python, but at least some programming language, and then you are familiar with the constructs like looping, conditional statements, functions, and to certain extent, the ideas in object-oriented programming like classes, objects, methods. So this is our basic idea. So if you are not comfortable with these ideas, now we can have an extended discussion on these basic ideas in our live sessions. But in this tutorial, we will be going ahead and assuming that you know these prerequisites, and then we will be skimming through these ideas of looping, conditional statements, functions, and classes. In addition to that, we'll be looking into some of the very interesting data types in Python: lists, tuples, dictionaries, and sets. Okay, that is the plan for our discussion for the day. So, without any further delay, let's jump into these things. So, we will be, as I told you earlier, we will be using Colab, Google Colab. Now, if you just go to your Chrome or Firefox or whatever uh, web browser that you are using, you just type Google Colab there. You will it will be taking you to the page of Google Colab. From there, you can redirect yourself to a page to this Google Colab. Now, people who are familiar with Jupyter Notebook, now it is similar to Jupyter Notebook running on a cloud. Now here you can change the file name, and it is IPYNB, Interactive Python Notebook. So let's run the first instruction, which is hello world always. I just have written something. So let's use the same thing. Hello world. So people who might be familiar with a couple of other programming languages like C or C++, so you don't need to include any of the libraries or any of the packages. So all of them are present. You can directly start going ahead with it. Now, whenever we need extra packages, during those times, I'll tell you how to go ahead with that. So this is a code block. So you can also have text block. To run a code block, you just click on this play button. Now it's a print statement, the standard. So if you are from C, it's printf. So this is the string input that you are giving. This is a function. The print is an inbuilt function which takes the string input and then process it and gives the output. Okay. This is about the basic print statement that is needed. Now let's look into the data types. And okay, now before that, the variable naming convention. The variable naming conventions are pretty standard. Now that is, now you are the allowed characters are capital A to Z, small a to Z, 0 to then underscore, and you cannot start a variable name with a number. Okay, and then you cannot have keywords as variable names. Now the pretty standard uh, rules on the variables holds true. So now let's take list into consideration. Okay. Now the data types that we shall be looking is list, tuples, dictionary, and then sets. Okay. Now these are the data types that now we shall be looking. Now a list is a collection of items. Okay. So, and it should have some properties. Now, what are the properties? Now, list is mutable. That means you can change the entries. And then ordered. That means you have indexing and allows duplicates. Okay. Now, tuples, on the other hand, are also collection of items, but they are not mutable. That means that you cannot change the contents. Once you have defined, it's there. Okay. You cannot change the contents. It's also ordered. Okay, and allows duplicates. And dictionary, now standard to the English or any language dictionary that we take, now where in which you are you know the word and then you need to know the meaning of it. So here the key and the value pair is a, okay, here also it's a collection of key value pairs. Okay, so it's a collection of key value pairs and ordered with respect to keys. Now that means that if you want to access a value, so the way to get it is via the keys. Okay, and then so cannot have multiple keys with same name. Okay, but you can have multiple values under different keys. Now, that is fine. It is ordered with respect to keys, and you cannot have multiple keys, and it's changeable. Okay, that is mutable. You can change it. Now, sets are again collection of items. Okay, it is unordered. It's unordered. Okay, and then does not allow duplicates. Does not allow duplicates. Okay, and changeable. These are mutable. Okay. Now you can see depending on the need, you can choose what kind of data type that you want to use. Now, these are the advanced data types. Now, the basic data types, that is an integer, a floating number, a string, and a boolean. Now, they are similar. Okay, there is no change in them. Okay. And arithmetic operations, relational operations, all those things. Okay, the outcome of a relational operation is a boolean value. So the kinds of arithmetic operations that we had in other programming languages, now all of them remains intact. Okay. So now let's go into the list. Okay, let's take the list into consideration. Okay. Now, since list is a collection of items, now that is, let's say that I have var1. Now, I'll say since it's collection of items, what kind of items can be there? Now, it can be basic data types or advanced data types. Now, all of them are possible. I'll just, for the simplest uh, demonstration purpose, I'll take everything as numbers. Okay. Now, this is unlike the array in C, where in which all the entries should be same. That okay. Let's see that first. 1 comma 12.4, 12.5, 3.14. Okay, so then if I'll just print var1. And if you want to know what kind of data type it is, you can always use type of var1. If you see it, so it's possible. It's a list. It's a class list. Now see here, the list that you have created var1 is actually an instance of the list. Okay. Now these are the contents. Now these are the attributes, and then now since it's an instance, now it can invoke methods. Now the methods that can be invoked are for adding a new entry or removing an existing entry. See, since it's mutable, that means you can change the contents. Okay, so that means that you can add an entry or you can remove an entry. So now let's look at adding a data. Okay, add data. Now, whenever I say add data, now the immediate question is add where? Where to add it? Okay. So now, do you want to add it at a specific index? Okay. Add it at a specific index, or simply add it at the last. Add it at the last. Now, whenever you want to add it a specific index, now the method that we invoke is what is known as insert. If you want to add it at the last, the method that we invoke is what is known as append. Okay. Now to understand this, let's take a simple list, create a var2. Now you use big brackets, as you can see from the previous example, to indicate that it's a list. We use big brackets. 1, 2, 3, 4, 6, 7, 5, 9. Okay. Now these are things. Now if you want to say that you want to add 8. Okay. Now if you want to add 8 at last, that is var2 dot append 8. Okay. Now print before, just to understand the addition properly, adding the element properly, print after var2. So now here you can see that this print function is taking two arguments. One is a string, the other is this list itself. Okay. As you can see here, this is before, and this is after. You have added at the last. This is append. Now, similarly, you can insert. Now, let's say that I want to insert 12. Okay. I'll just copy this. Now you don't want to append, you want to insert. Now, whenever I say insert, insert where? You want to specify an index. Okay. Now let's say that I want to insert it at index 5. And similar to all of the earlier programming languages, the index starts from 0. Okay. So what is that you want to add? You want to add, okay, just for indication, let's put a name. So At an index 5, 0, 1, 2, 3, 4, 5. That means wherever 7 is there, now Chandan should come and this 7, 5, 9, 8 will be pushed. Okay. As you can see here. Okay. This is how you can add an element. Okay. Now I have just, for the sake of demo sake, I have just shown you adding of one element. Similarly, you can add a list of elements, all those demos possible. Okay. So now then let's look at the remove. Now, whenever I say remove, now again, here also the question arises, remove which element? Okay. Now, do I need to just, the first case is remove the last element, or you want to remove the specific element, not worrying where it is present, irrespective of its presence in the list. I just want to remove that element. Remove the specific element, not worrying about its index. Not worrying about its index. And the third way is remove an element at a specific index. Element at a specific index. Okay. Now these are the three different cases. Remove the last element. No, you are not worrying about which element it is. No, just whatever has been recently added. Now, assuming that you have used append, so you remove the last element, or remove a specific element at an wherever it might be, or remove an element at an index. Okay. Let's see example for each of them. Okay. So now let's to remove the last element, we use what is known as pop. To remove a specific element, we use remove. Okay, you specify the element, and then you want to remove an element at a specific index, we use pop with the index. Now these are methods you want to call with this instance. Okay, now okay, print before var2, print after. Okay, so now I'll say var1 dot pop. Oh, sorry, it has to be var2, right? Yeah, sorry, var2 dot pop. So the last element which is there, 8, is being removed. Okay, and then you can have remove a specific element irrespective of its index. Remove, let's say, and then okay. Now this is being removed. Now you want to remove a specific index. So now let's say that I want to remove the index 2, 0. You have to see here 0, 1, 2. Now 3 has to go off. Okay. Now this will give you an idea of the ordering as well as its property of mutable. Okay, that means that you can change things. Okay, so now allow duplicates, you can have multiple elements. I'll not be going ahead with that. So just now one. Okay. Now these are some of the very important properties that are there in the list. Okay. Now one of the great advantage of this is you can have different kinds of data. Now, if you have known the array in C, now you fix the type and then till the code completes that date, that variable will only have an array with the homogeneous elements. But even though you have all numbers, you can add a string, remove a string, or for that matter, any other data type can be added. Now, because of which the list is quite flexible. Okay. Now, because of that reason, most of our operations will be centered around a list, easy to handle. Okay. So now the tuple which is there is similar to list, but the only problem with the tuple is it's not modifiable. Now that means that adding and removing, none of these operations are there. That means that whenever you're looking at a tuple, you can only look at the order and then whether duplicates are allowed or not. Okay, so tuple, to declare a tuple, now let's say I'll use var3, you have to use parentheses. Okay, now print var3 and then you can print type of var3. Let's put duplicates 1 comma 2 comma 1 comma 3 comma 3. Okay, so now this is just to indicate you that it allowed duplicates. Okay, and then print var3 of 5. Okay, 0 1 2 3 4 5, so I have to read 7. Okay, 7. Now it allowed duplicates and then it's ordered. Now please see here, while indexing you're still using uh, the big brackets. Okay, indexing irrespective of the data type that you have, we always use big brackets. Okay, this is regarding the tuple. Now let's look at the next one now, which is dictionary. So while declaring a dictionary, you use these flower braces. Now it's a key value pair. So now you have to specify the key. Now let's say name Chandan, comma, age 35. So roll number, let's say 182. So this is the key, this is the value, this is the key, the value. You can have key value pairs like this. So now print var4 if you want to access the name. Okay, as I told you, it is ordered via keys. Now if you want to access the value, you have to access it via key. In addition to that, print the whole dictionary once and the type of it. Okay, so you access them via the keys. So the next now I have to show you that it's changeable. Now how do I show that it's changeable? I'll change an entry and add a new key value pair. Let's say that var4 of age, it becomes 36. Okay, it says print always before and after, just to show that it's var4. Okay. You can see that this 35 here, I can modify a specific entry. Okay, I can modify a specific value. Now, similarly, you can add a new key value pair. Now, let's say that I'm adding my address. Okay, so I'm adding my address here. You see that it has been added. Okay, this is how you can modify the entries. Okay. So now the next data type that we shall be looking into is set. Okay. Now set is, it's a collection of items which are unordered. That means that there is no indexing. Okay, of 3 or 4 you cannot get any of that. It's unordered, doesn't allow duplicates, and it's mute. You can change the element. Now whenever I say that change, that means that you can add an element or remove an element. Now here, now please remember, you cannot add with respect to an index because the indexing itself is not there. Okay, so now you can add an element. It will just be added to that set. Okay, adding at a specific index doesn't make any sense here because the indexing itself is not there. Okay, now please keep that in mind. So now to create a set also we use flower braces, but please remember the difference between the dictionaries and then the set. So whenever you are dealing with a dictionary, you have a key value pair, but here you don't have a key value pair. You just have some entries. You have just some items. Okay. So now let's run this and see that it's a set. Okay. And let me show you that. Let me do this 9, 5, 6, 6, 4. Okay. I'm trying to repeat the element and I'll run it. Now you see that even though you have repeated, it's not reflected. And the reason is it doesn't allow duplicates. Okay. So, and you cannot access an element, it will throw you an error. You can just give it a try. Okay. Indexing it. Now adding an element is so print before var 5, then var 5 dot add. Now which element I want to add? Let's say that I want to add 8. Okay, and then to that, okay, now 8 is not there, it has been added. See, just because it has put 8 before it is not an indication that it is doing it in ascending order. Okay, only in this case somehow it has done it. There is no order to it. Okay. Similarly, you can remove. Now to remove, we use remove. Let's say that I want to remove 5. Now, not the index 5, the element 5 here. The element 5 remove. Okay. Okay. So now it has been at the 5th index. So please remember. Okay. Now let's say that I want to remove the index. I want to remove the element 9. Okay. It has nothing to do with the index. Okay. Similarly, you can do all the standard set operations like union, intersection, set difference, and stuff. Okay. Now this is regarding the data types that are there in Python. So now the next thing that we shall be looking into is looping. Okay. Now the first, there are two loops. Now you have a for loop and then while loop. See, for loop is used when I know how many times the iteration has to happen. We will use while loop. So when we don't know how many times an iteration should happen, but we know when to stop the iteration. Now that is when we use while loop. There is a condition. Depending on that condition, the iteration depends on whether the condition is satisfied or not satisfied. Now we can do it. Now for loop is used when you know how many times you have to iterate. Okay. Now let's look at the for loop. For loop. Now since we know how many times you have to iterate, now for I in range of 10. Now this range of 10 will give you 0 to 9, and then during each iteration the next value will be assigned, and then you go inside and print it. See, Now here, one major difference that we should know is regarding the indentation. Okay. So in some of the programming languages, we have braces, curly braces, flower braces to indicate what are the instructions that needs to be repeated. But here in Python, no, we don't have any kind of braces like that. Now we use indentation for it. Now, whatever instructions that comes after this in this block, now those will be, what do you call, iterated upon. Now, for example, I'll say print hi. So now that means that now these two instructions, I'm just showing you to preliminary instructions, but yeah, you can replace that with any instruction and then understand that, okay, see now for each iteration, now these two things will be repeated. So now, and then finally, print hello. Now this is outside of this indentation. Now you can look at this, okay. Now once you are done with this for loop, now you'll go here. Now the indentation is the idea here, okay. You can see 0 high and hello is only coming once. That is post this for loop. Okay, first I will get the value 0 and then it will go inside the loop, do this, and then I will get the value of 1. So you don't need to increment the value. Okay. So now, for example, you want it to be in the steps of 2. Okay. Now you want to start from 0 and then you want these things to be in steps of 2. Then you can do it like this 0, 2, 4, 6, 8. Now the first number is the starting number. This is the ending number. Now it is always one less than that. Similar idea. And at the steps of 2. So you get 0, then you get 2, then you get 4. You go it like this. For example, you can say from 5 to 128 at the steps of 25. We can do something like this. Okay, 5, 30, 55, 80, 105. Okay. Like this it will happen. So three numbers. The first one is the starting point, the ending point, and the step size. Now, if you don't specify, okay, let's say that you just specify 5 here. Now, this is the last. That means by default it is starting from 0. If you say that no, you start from 2. When you have two numbers, the first one is the starting point, the second one is the ending point. Okay, only with three numbers, the starting point, ending point, and step will be considered. Okay. And this is the for loop. And then to go ahead with a while loop, one of the standard examples that people will always give is the Fibonacci sequence. I assume that all of you know the Fibonacci sequence 0, 1, and the next is 0 plus 1 is 1, then 1 plus 1 is 2, 2 plus 1 is 3. You take the last two previous and then you go on adding. Okay, the standard Fibonacci sequence. So now the idea to go ahead is now I will give you a number, okay, generate fib series, okay, of numbers less than the given number. So let's say that I'll give you 20. Okay, so number, I'll give you the number equals 20. Now what should be the output? 0, 1, 1, 2, 3, 5, and then 8, then 13, then comes 21, but 21 is greater than 20, so you'll stop. Now I don't know how many times I have to iterate. I just know till the generated number is greater than the given number. Till that point I have to reiterate. Now I know a condition. Till that condition is satisfied, I'll be going ahead. So to do that, it's the idea is very simple. I'll just decide, let's take 20 itself. The number is 20. Fib 0 equals 0. Then fib 1 is equal to 1. Then you print fib0 and fib1. Okay, and then you use while fib1 is less than num. Okay, so fib0 comma fib1. Okay, so now here, now this is how we do it. While fib1 is less than num, so the current one is less than 20, true. Now then what you will do, you'll put the fib1 which is 1 to 0 and then 0 plus 1 to this. Okay, now it's like this first one will be assigned to this, and then to this second one this value is assigned. Okay, this is something that is not there in C, but it is there in Python. Okay, now if I do this, now 21 is coming. The reason why 21 is coming is because you have put the print later. You can modify it. Okay, now 21 is generated and 21 will come here, and then it will go on check. Okay, I assume that all of you are capable enough to modify this. I have deliberately made this mistake so that you can rearrange this and then you can get only these as the output. Okay, so now this is the looping, for loop and while loop. For loop is used when you know how many times you have to iterate. While loop is used uh, when you know that, okay, there is a condition, till that condition is satisfied, I'll be going ahead with the iterations. Okay, and then we will look at the conditional statements. Now here we have if block will be there, if else will be there. Okay, and then you have if else if block will be there, and then if else if else will be there. Okay, see here in Python we don't have switch. Okay, so no if, so when some condition is satisfied, you take a certain instruction, you execute certain instructions. Now, that is when you use if. Now the second one, if else, is when some condition is satisfied, you do something. If the condition is not satisfied, you do something else. Okay, now that is your whole execution is divided into two parts. Now the third one is if else if. So you check for the first condition. Okay, if first condition is satisfied, now then you execute the instructions for that condition. If the first condition is not satisfied, then you check for the second condition. Okay, if the number is divided by 2, you do something. If the number is not divided by 2 and then it is divided by 5, then you do something else. Only when the first condition or the previous condition is not satisfied, okay, you go to the next condition. Okay, now here there is no default argument. Okay, like so if none of the condition is satisfied, now then you do what is not there. If you even include that, it will become if else. We will take a very simple thing. Okay, so now I'll give you a number. Now you just say that it is divisible by 2 or not. Okay, even or odd. I'll just give you a number. Let's say that the number is 13. If num mod 2, now num mod 2 will give you the remainder. Okay, the modulus operator is used to give you remainder, and then you're checking that is this remainder equal to 0. Okay, now this is a conditional statement. You're checking some number is equal to another number. It can only give you two options, either it is true or false. If it is true, now you just print even. Now if it is not true, you print odd. Okay, it's odd. So if it is 12, This makes sense? Okay. Now, if this condition that is being checked, this is a relational operation, if this is true, then the indentation, please look at the indentation, this will be satisfied. If the condition is false, then this will be satisfied. These instructions will be executed, sorry. These instructions will be executed. Okay. And if you don't have the else part, then it is the standard if statement. Okay. Now, this is how you have if else. Then you can have if else if. Now, a simple again, if number, I always prefer to, if number mod 2 equal to 0, then you say that print divisible by 2. Okay. Now, if it is not divisible by 2, that means that the remainder is not 0. Then elif else if. Okay, you do this. Now, if it is not divisible by 2 and it is not divisible by 3, then again you'll check whether it is divisible by 5, and then you'll finally have an else block. If none of this is true, okay, then print not divisible by 2, 3, 5. Okay, the number is 12, it is divisible by 2. So, and see that it is also divisible by 3. But why is it not printing divisible by 3? Because once this condition is satisfied, if this is executed, it will come out of this whole block. It will not go into, only when this condition is not satisfied. For example, let's say that number is 15. Then it is saying divisible by 3. Why? The first condition is giving you false. No, because of which you will check the second condition. Okay, but it is true. Now, when you divide 15 by 5, then also you get the remainder 0, but that itself is not being checked. Okay. This is regarding the conditional statements. So, if you remove this else, then it will be if else if blocks. Okay. Now, this is regarding the conditional statements. And then, so the next idea is functions. Okay. Now, functions is you put these depending on the need to go ahead with modularity. You don't want things to be as one, one block of code. You want them to be modularized. And therefore, what do? You put them into multiple functions. Okay. So you use def to define a function, and name of the function can be any valid variable, and then you can give an argument. Let's say that I'll give num. Okay. Now, what is the functionality? What is that this function is supposed to do? Now, it should tell me all the numbers that divides this num. Okay. Now, let's try to understand that problem. Now, let's say that I'll give you my number is 12. Then my output should be 1, 2, 3, 4, 6, 12. Okay. I should be getting this. Now, 1 and the number itself is always true. So, yeah. Now, how do you do it? Now, first, now let's say that now these are factors. It's 1, num itself. And this will be there always. And then, okay. Now, then you return factors. Okay. Fine. If you want to give another number, let's say that you want to give 7. Okay. Now here you're bringing in these under one roof, that is the function. This will be executed only when a function call is made. Okay, this is the return value. This is the argument that you have. Okay. Now, if you want to fix some default arguments, now you can fix it later. Okay, after these formal arguments, you can fix default arguments and then you can modify them. Okay, at the need, when we will be going ahead with other specific functionalities, at that time we will look at the default arguments and how do we code with them in some other coming tutorials that we shall have. Now, this is what we assume. At least you should be knowing these basic ideas of Python. Okay. Now, to give you a recap of what are the things that we just looked at, we looked at different data types that are there. Now, how do they differ from each other? Now, if you want a collection of items where which you can change the entries, you want them to be order and duplicate should be there, now then you should use list. If you want the collection to be just items and then they should not be modified but allow duplicates, okay, then you should use tuple. If it is in the format of key value pairs, then use dictionary. Now, if you want unique set of unordered items, then you should use set. Now, we worked with each of them in brief, and then we looked at the looping, the for loop, and then the while loop, and then we looked at the conditional statements, and then a very simple function. Okay. Now, with this, we conclude this tutorial. Now, the advanced ideas that are needed, like classes, objects, and remaining things. Now, when we start programming, at the time of need, we will be introducing them. But as of now, this much is needed for our working for some amount of time. Thank you all for patiently being there in this tutorial. We'll meet you in next tutorials. Thank you. Bye-bye. Have a nice day.